Hello all. In this video we will see the GATE syllabus for newly introduced subject Environmental Science and Engineering. So GATE 2021 onwards this subject will be newly introduced for GATE examination. Session 1 Mathematics Foundation, Linear Algebra, Determinants and Matrices, Systems of Linear Equations, Eigenvalues and Eigenvectors, Calculus, Functions, Limit, Continuity, Differentiability, Local Minima, Maxima and Minima, Taylor Series, Tests of Convergence, Definite and Indefinite Integrals, Application of Definite Integral to obtain area and volume, Partial and Total Derivatives, Differential Equations, Linear and Nonlinear First Order Ordinary Differential Equations ODE, Higher Order Linear ODEs with constant coefficients, Cauchy's and Euler equations, Laplace transform and its application in solving linear ODEs, Probability and Statistics, Descriptive Statistics, Measurement of Central Tendency, Dispersion, Skewness and kurtosis, Probability Concepts, Conditional Probability, Bio's Theorem, Risk and Reliability, Probability Distributions, Correlation, Single and Multiple Regression Models, Hypothesis Testing, T-Test, F-Test, Chi-square Test. Session 2 Environmental Chemistry, Fundamental of Environmental Chemistry, Covalent and Ionic Bonding, Chemical Equations, Concentration and Activity, Structure and Chemistry of Organic Molecules, Radioactive of Elements, Chemical Equilibria, Thermodynamics and Kinetics of Chemical Reactions, Principle of Water Chemistry, Water Quality Parameters and their Measurement, Acid-base Equilibria, Buffer Solution, Carbonate System, Solubility of gases in water, Complexation, Precipitation and Redox Reaction, Inorganic and Organic Contaminants in water under speciation, Soil Chemistry, Organic Matter, Nitrogen, Phosphorus, Potassium, Cation exchange capacity, base saturation and sodium absorption ratio, Atmospheric Chemistry, Composition of the atmosphere, Reactivity of trace substances in the atmosphere, Urban atmosphere, Smog and particulate pollution, Chemistry of ozone formation, Chemistry of stratosphere. Session 3 Environmental Microbiology, Prokaryotic and Eukaryotic Microorganism, Characteristic of diverse groups of microorganisms, Classification of microorganisms, Microbial diversity, Plant microbe and soil microbe interactions, Role of microorganism in wastewater treatment, bioremediation and geochemical cycling, Cell chemistry and cell biology, Structure of proteins, nucleic acid, DNA and RNA, lipids and polyacylates, bonds in biomolecules, stereoisomerism in biomolecules, structure of cell, structure and function of cytoplasmic membrane, cell wall, outer membrane, glycocalyx, chromosomes, endospores, storage products, mitochondria and chloroplast, microbial metabolism, anabolism and catabolism, phosphorylation, glycolysis, TCA cycle, electron transport chain, fermentation, anaerobic respiration, energy balances, enzymes and enzyme kinetics. Growth and control of microorganisms, bacterial nutrition and growth, specific growth rate and doubling time, Monod's model, types of culture media, batch and continuous culture, effects of environmental factors on growth, control of microbes using physical and chemical methods, microbiology and health, pathogens and modes of transmission, indicator organisms, quantification of coliforms using MPN and membrane filtration techniques. Session 4, Water resources and environmental hydrolysis. Global water resources, structure, properties and distribution of water, water quality, treats of water resources, water conservation. Surface water resources, hydrological cycle and water balance, precipitation, infiltration, evaporation, evapotranspiration, runoff, flow hydrographs, unit hydrographs, stage discharge relationship, reservoir capacity, reservoir and channel routing, surface runoff models, surface water management, rainwater harvesting and storage. Groundwater resources, geologic formations of aquifers, vadose and statured zones, saturated zones, confined and unconfined aquifers and their parameters, porosity, permeability, transmittivity, and storage coefficient. Darcy's law and applications, steady state well hydrolysis, environmental hydrolysis, concepts of mechanics, properties of fluids, pressure measurement, hydrostatic force on surface, buoyancy and flotation, laminar and turbulent flow, flow through pipes, pipe networks, boundary layer theory, forces on immersed bodies, flow measurement in channels and pipes, kinematics of flow, continuity, momentum and energy equations, channel hydrolysis, specific energy, critical flow, hydraulic jump, rapid and gradually varied flow, design of line and unlined channels. Water and wastewater treatment and management. Water and wastewater quality parameters, eutrophications and thermal sterification in lakes, river pollution, oxygen cycle curve, water treatment methods, screening, sedimentation with and without coagulation, filtration, desalination, disinfection, water distribution and storage, point and non-point sources of wastewater, population forecasting methods, design of sewer and stormwater sewers, sewer apprentices, preliminary, primary, secondary and tertiary sewage treatment, sludge generation, processing and disposal method, sewage farming, sources and characteristics of industrial effluents, concept of common effluent treatment plants, CETP, wastewater recycling and zero liquid discharge, kinetics and reactor design, mass and energy balance, order and rate of reactions, batch reactors, completely mixed flow reactors, plug flow reactors. Air and noise pollution, structure of the atmosphere, natural and anthropogenic sources of pollution, atmospheric sources, sink, transport, indoor air pollution, effects on health and environment, air pollution, gases and particulate matter, air quality standards, primary and secondary pollutants, criteria pollutants, ambient and source standards, air quality indices, visibility. Particulate pollutions, measurement and control methods, control of particulate air pollutants using gravitational setting chambers, cyclone separators, wet collectors, fabric filters, baghouse filter, electrostatic precipitators. Gaseous pollutant, measurement and control methods, control of gaseous contaminants, absorption, condensation and combustion, control of sulfur oxides, nitrogen oxides, carbon monoxide and hydrocarbons, vapor liquid and liquid solid equilibria, diffusion, Fick's law and interfacial mass transfer, automatic emission control, fuel quality, diesel particulate filters, catalytic converters, air quality management, point line and area sources, inventory, influence of meteorology, wind, rose diagrams, stability, mixing height, topography, dispersion modeling, monitoring, noise pollution, sources, health effects, standards, measurement and control methods, solid and waste management, integrated solid waste management, waste hierarchy, rules and regulation for solid waste management in India, municipal solid waste management, sources, generation, characteristic, collection and transportation, waste processing and disposal including reuse options, biological methods, energy recovery processes and landfilling, hazardous wasting management, characteristics, generation, fate of materials in the environment, treatment, disposal, soil contamination and leaching of contaminants into groundwater, management of biomedical waste, plastic waste and e-waste, sources, generation and characteristic, waste management practices including storage, collection and transfer. Section 8. Global and regional environmental issues. Global effects of air pollution, greenhouse gases, global warming, climate change, urban heat, highlands, acid rain, ozone hole, ecology and various ecosystems, biodiversity, factors influencing increase in pollution, energy consumption and environmental degradation. Session 9. Environmental management and sustainable development, environmental management systems, ISO 1400 series, environmental auditing, 14,000 series. Environmental auditing, environmental impact assessment, life cycle assessment, human health risk assessment, environmental law and policy, objectives, polluter pay principle, precautionary principle, the Waste and Air Acts with amendments, the Environment Protection Act EPA 1986, National Green Tribunal Act 2010, National Environmental Policy, Principle of International Law and International Treaties. Energy and environment, energy sources, overview of resources and reserves, renewable and non-renewable energy sources, energy environment nexus. Sustainable development, definition and concept of sustainable development goals, hurdles to sustainability, environment and economies. So this is the newly introduced GATE syllabus for environmental science and engineering. From GATE 2020 onwards, this syllabus will be followed. Thank you so much.